In this video, we're going to work through a practice problem on limiting reactant and excess reactant. This problem is pretty straightforward, so if you're just starting out learning limiting reactant, this is a great place to begin. We're going to use this equation to answer the following questions. What is the greatest amount of MgO, magnesium oxide, in moles that can be made with 7.8 moles of Mg, magnesium, and 4.7 moles of O2, oxygen? Which is a limiting reactant, which reactant is in excess, and how many moles of it are left over? So this problem is all about moles. How many moles of this do we have? How many moles of this can we make? So I want to put this information about the number of moles that we have, I want to put this front and center. All right, we have 7.8 moles of magnesium and 4.7 moles of oxygen. This is what we're starting with. We're going to keep referring back to this information through the whole problem. Okay, so we want to find the greatest amount of magnesium oxide that we can make with this amount of magnesium and this amount of oxygen. In order to do that, we've got to figure out which of these two things is the limiting reactant. Is it magnesium or is it oxygen? To figure out which of these is a limiting reactant, we're going to ask a few questions. Okay? First, we're going to ask, to use all of the magnesium, how many moles of oxygen do we need? Then we'll kind of ask the reverse. We'll flip it around and we'll ask, to use all of the oxygen, how many moles of magnesium do we need? We'll look at the answers from these two questions and we'll figure out which of these runs out first. And the first reactant that we run out of, that is the limiting reactant. Okay, so let's go ahead and start with this question. I'm going to get rid of this paper right here so we just have a little bit more space. And we want to find out, to use all of the magnesium, how many moles of oxygen do we need? Okay, so we're starting with a maximum amount of magnesium. That's 7.8 moles of magnesium. How much oxygen do we need to react with that? Well, I'm going to multiply this by a conversion factor that shows the relationship in this equation between moles of magnesium and moles of oxygen. Okay, there's a 2 in front of the magnesium. There's nothing in front of the oxygen. That means it's really a 1 here. We could write this in to make it a little easier. It's always a 1 if there's nothing in front of the compound. So this equation is telling us that there are 2 moles of magnesium for every 1 mole of oxygen in this reaction. Okay, so I want to get rid of moles magnesium. So I'm going to put moles of magnesium on the bottom. I have 2 moles magnesium, and then I have 1 mole oxygen on the top. Okay, so moles magnesium on the top, moles magnesium on the bottom. These cancel out, and the math is going to be this times this divided by this, which gives me 3.9 moles of oxygen. So what's this telling us? Well, it's telling us, if we want to put this in words, it's telling us that we need 3.9 moles of oxygen to use all of the magnesium. Okay, so we're going to put this right here. This is how much oxygen we need to use all of magnesium. Now, let's ask the same thing about the oxygen. To use all of this oxygen, how many moles of magnesium do we need? Okay, so we're starting with 4.7 moles of oxygen. And we're going to multiply that by conversion factor that gets us to moles of magnesium. So what's the relationship here? 2 moles of magnesium for 1 mole of oxygen. So I'm going to put moles of oxygen on the bottom. 1 mole oxygen. 2 moles of magnesium on the top. 2 moles Mg. We have moles O2 on the top, moles O2 on the bottom. This times this divided by this is going to give 9.4 moles of magnesium. Okay? And to put this into words, just like we did before, this is telling us that we need 9.4 moles of magnesium to use all of the oxygen? Okay, so now that we've answered these two questions, we can figure out which of these two things is the limiting reactant. Okay, which do we run out of first? Check this out. To use all of the magnesium, we need 3.9 moles of oxygen. Is the oxygen going to run out if we do that? Well, it's not, because we have 4.7 moles that we're starting with. We only need 3.9 to use all the magnesium. So it doesn't look like oxygen is going to run out in this situation. Now, down here, to use all of the oxygen, we need 9.4 moles of magnesium. Is that going to work? No, it's not, because we only have 7.8 moles of magnesium. That means that we don't have enough magnesium to use all of the oxygen. It means that magnesium is going to run out. It's going to be the first reactant to run out, so it is going to be the limiting reactant. In other words, we could say this. We could say that we have enough oxygen to use all of the magnesium, right? We have the 3.9 moles that we need. We have more than those 3.9 moles to use all the magnesium. We have enough oxygen to use all the magnesium, but we don't have enough magnesium to use all of the oxygen. We need 9.4 moles, we only have 7.8 moles. We don't have enough magnesium to use all the oxygen, so that means that magnesium is the limiting reactant. We don't have enough, it's going to run out. So now that we know that magnesium is a limiting reactant, we can figure out the greatest amount of magnesium oxide that we can make. Okay? What are we going to start with and how much of it? Okay, let's go back to this statement. We have enough oxygen to use all the magnesium, but we don't have enough magnesium to use all the oxygen. So that means that to make magnesium oxide, we're going to use all of the magnesium. We can't use all of the oxygen, okay? As you can see here, magnesium is a limiting reactant, so you're always going to start with a maximum amount of the limiting reactant. Okay, so we have 7.8 moles of magnesium, and we're going to multiply this by a conversion factor that shows a relationship between moles of magnesium and moles of magnesium oxide. They're both 2. So on the bottom, I'll put 2 moles Mg. On the top, I'll put 2 moles magnesium oxide. Now we have 2 over 2. This is the same as 1, so it's actually not going to really change this number at all. We have moles Mg, that cancels out. And 7.8 times 2 divided by 2 is just the same as multiplying it by 1. We're going to get 7.8 moles of MgO, magnesium oxide. And this tells us the greatest amount of magnesium oxide that can be made here, starting with the maximum amount of the limiting reactant. Now finally, let's talk about excess reactant. How much reactant is left over? Okay? We use the maximum amount of magnesium for making the magnesium oxide, but we don't use the maximum amount of oxygen, okay? So let's figure out how much oxygen we need to combine with the maximum amount of magnesium. Well, we actually already did this. We did this calculation at the beginning of the video, and this is what we came up with. We need 3.9 moles of oxygen to combine with 7.8 moles of magnesium. So this is the amount of oxygen that we're going to need when we're making the magnesium oxide and starting with the maximum amount of magnesium. So to figure out how much is left over, to figure out the excess reactant, it's a relatively straightforward equation. Okay? What we're going to do here is we're going to start with the total reactant, which is 4.7 moles of oxygen. And then we're going to subtract the amount of the reactant that we use, which is 3.9 moles of oxygen. And that's going to give us 0.8 moles of O2 left over. That's the excess reactant that we don't use. So that's how you solve a problem like this with limiting reactant and excess reactant. First, you figure out which of your reactants is the limiting reactant. Then, using the maximum amount of the limiting reactant, you figure out how much product you can make. The excess reactant is the amount of the other reactant that you don't use the full amount of. You just take the total, you subtract the amount that you did use, and you end up with the excess. Okay, so this is a relatively straightforward problem. Once you feel comfortable with this, I recommend you check out some of my other videos on limiting reactants so you can see some more challenging problems where, along with doing this kind of math, you also have to spend time converting back and forth between grams and moles.